Exercise 10.03 is about differentiation of exponential functions. Now, as we saw in the previous exercise, the derivative of e to the x is equal to e to the x, which makes it really easy to differentiate. So here's the first example. So the derivative of this function, 3x minus 2 e to the x. So derivative of 3x we've seen before is just equal to 3. So you can think of it as the gradient of 3x is just 3 if you've got a straight line. And this one, well, the 2 doesn't affect it at all. That's just like in the past when we had 3x here, 2 times something, the 3 stays, and in the same way the 2 will stay, and e to the x differentiates to e to the x. That's the answer. Example 2 is y equals e to the 3x. Now we do need to use the chain rule here. So remember, the derivative of the function is equal to the derivative of the inside times the derivative of the outside. We have seen that before. So the derivative of the inside would be the derivative of 3x, which is 3. And then the derivative of the outside is just e to the 3x. Now, we could have done that using a formula as well. So we could have made this e to the u. The formula is dy dx equals dy du times du dx. Remember, that is on our reference sheet. So dy du is the derivative of this. So dy du just equals e to the u. Du dx, well, u equals 3x because that's what we've replaced. So therefore du dx just equals 3. And we can see if we do dy du times du dx, that's 3 times that, those two things multiplied together, which is exactly what we've got here. Okay, this third example is a chain rule again. So I'm just going to say derivative of the inside times derivative of the outside. So derivative of the inside, 5 differentiates to 0, e to the x differentiates to e to the x. So derivative of the inside is e to the x. And that's multiplied by the derivative of the outside, which is where we just bring the power down. We rewrite the brackets and we reduce the power by 1. Now, as a final answer, and you can go straight to this final answer if you want to, I would write the 4 first. So the 4 out the front, then the e to the x, then the 5 plus e to the x, and then the power. Number 4 is a quotient rule question. So I am going to lay it out how we normally would for quotient rule. So u is the top and v is the bottom. So du, actually let's do it u dashed because we'll use that formula that we learnt rather than the reference sheet one. So u dashed, 2 goes to 0, e to the x is e to the x. V dashed, 5 goes to 0, the negative will have to stay, so negative e to the x. So if I now differentiate that now, dy dx, remember it's u dashed v minus v dashed u all over v squared. So u dashed v is these two multiplied together. So e to the x times 5 minus e to the x. Minus v dashed u, which is those two. Now this is going to be negative again, so that negative will become a plus. E to the x times 2 plus e to the x, all divided by the denominator squared, so 5 minus e to the x squared. Now that numerator can actually be tidied up quite a lot. I'm actually just going to come over to the side here. I didn't leave myself enough space. So it becomes, so I'm going to factor out the e to the x. I've got 5 minus e to the x plus 2 plus e to the x, all divided by the denominator squared. And in the brackets there, that's just 7. So 7e to the x over 5 minus e to the x squared. And when it tidies up that nicely, you really do need to do that. Okay, so example 5 is a product, so we need to use the product rule. So u equals 7 minus x, v equals 3x plus e to the x. So u dashed is negative 1, and v dashed is 3 plus e to the x. So the derivative, remember, is u dashed v plus v dashed u. So the same as the top of the quotient rule except with a plus. Okay, so u dashed v is minus 1 times that. So negative 3x plus e to the x. Plus v dashed u, so that's those two multiplied together. 7 minus x, 3 plus e to the x. Okay, now it is always worth considering what happens if you expand and simplify. This one, it looks a bit tricky to know whether it's going to expand and simplify nicely or not. Look, technically you can just leave it like that. But let's just have a look and see what happens when I expand it out. So negative 3x minus e to the x plus 21 minus 3x plus 7 e to the x minus x e to the x. So if I collect up a few like terms there, I might start with the 21 and then do these 3 x's, so minus 6x. I've got plus 6 e to the x and minus x e to the x. It really is debatable which way is the best way to leave it, really. The main thing here that could get really confusing for people is this 3x plus e to the x and the 3 plus e to the x. They're really similar, and it's really easy for people to think they can factorize that out, but they're not the same because of the x. If I did leave it in this factorized form, I would prefer to have the positive thing first, minus this, but that's fine either way. Okay, in this question we're asked to find the equation of the tangent to the curve y equals e to the negative 3x at the point where x equals negative a third. So the first thing I'm going to do there is I'm actually going to find the y coordinate at this point. So y equals e to the negative 3 times negative a third. So into this equation, negative 3 times negative a third is just positive 1, so y equals e to the 1, which is just e. So remember, that's that 2.718 number. Now we need to find the gradient of the tangent line, and remember we do that by differentiating. So y equals e to the negative 3x. So the derivative of that, we need to multiply by the derivative of the inside using the chain rule. So negative 3e to the negative 3x. And we want to know what the gradient of that tangent line is when x equals negative a third. So we do that by plugging that into our gradient function. So x equals negative 1/3. The gradient, so I'm just going to use m for gradient, equals negative 3e to the negative 3 times negative a third, which is just negative 3e to the 1, so just negative 3e. Now remember, if we were asked for the equation of the normal, you've got to find the negative reciprocal of that. But we won't ask for that here, we're asked for the tangent line. Okay, so the next step, remember, is to use y minus y1 equals mx minus x1. So our y1 and our x1 are the x and y coordinates of the curve, and our m is the gradient found from differentiating. So y minus e from there equals negative 3e x minus negative a third, so I'm going to make that plus a third. Okay, so let's see what we've got here. I'm going to start by expanding this out. Now remember, we can do general form or gradient intercept form, either way is fine. So that's 3 times a third is 1, so just e. Nice and convenient that we've actually got a minus e on each side, so if I just add e to each side, there we go with our gradient intercept form. We could leave it like that, or if we want to put it in general form, let's just add this to each side. So we got 3ex plus y equals 0 as our solution. Okay, in the last exercise we had a question where bacteria were grown in a petri dish. This is quite a similar question that was about exponential growth, whereas this question is about exponential decay. So it's decreasing rather than increasing. We've got a negative in the power, so think of an exponential function that's been reflected in the y-axis, so it's coming down like that. Where it crosses the y-axis is actually the amount you would have at the start, because time obviously has to start from 0. We can't have negative time. We're talking about the future. So in this question, a radioactive substance is decaying according to the function m equals 300e to the negative 0.004t, where m is the mass in grams and t is time in years. Find the mass initially. So initially is when t equals 0. So initially it's 300e to the 0, which is just 300 times 1, so just 300. We do need some units on there, and we were told that was in grams. In part B, we're asked to find the rate at which the substance is decreasing after 3 years. Now, the word rate tells us it's the derivative. Okay, derivative. So anytime you see the word the rate at which something's changing, so think like speed, for example, we can find velocity by differentiating. Anytime you see that word rate, you want the derivative. So the derivative of this function, we need to multiply it by the derivative of the power. So negative 0.004 times 300e to the negative 0.004t. And that happens to equal 1.2e to the negative 0.004t. And we want the rate after 3 years, so we do need to plug 3 into that equation. So t equals 3, m dashed equals 1.2e to the negative 0.004 times 3. And if you put that into your calculator, you're going to get, sorry, I've missed my negative. Negative 1.19. We do need units again. It is a rate, and it's negative 1.19 grams per year. Okay, the grams and the years. So we've got 300 grams, and after 3 years, 1 gram a year is decaying. That's the rate at which it's decaying. So you can see that's a pretty slow decay. Which is not surprising when you think of like nuclear waste and things like that, how it can decay very slowly over a very, very long period of time.